All right, would you like to kind of hear the rest of the problem thought through? Again, we decided that we're going to start at 1 on the y-axis because there's a 1 in front of the base. Now, I can shift to the right. I can shift down from, and this is where we got to be careful, from 1. So if I shift to the right, of course, that's going to move me 2 units over, but I'm going to shift down 4. But I already started at 1. So I got to do a little careful counting, We'll put you at the point 2, -3. 2, -3 is a point I want you to label. It's what I call the shifted starting value. Okay, now once you have that shift point, I guess it's kind of up to you what you want to do with some of this extra stuff. I feel like I want to just erase it so I'm not confused when it's time to draw the graph. I really don't even need that starting value anymore, okay, because that starting value shifted. There is a Y-intercept. I hope that the Y-intercept is something that you're kind of grabbing onto because it's always plugging in a 0. You always find it by plugging in a 0. Now, we want to be doing this without a calculator, so we realize that we're going to have to figure out 1/3 to the -2. All right, we can do it. 1/3 to the negative is going to require us to flip. We're going to flip the 1/3. Now, if you flip it, you get 3/1, but that's really just the number 3. But I flipped it because I want it to be a positive exponent. Now I can do the positive exponent. It's 3 squared, which is 9. So basically, we're working out what you get when you plug in a 0. You get a negative exponent, you flip it, make the exponent positive. So we get a nice, neat 5. Now 5, bless you, 5 is a Y-intercept. There's one more thing that, remember, we said everybody gets right. It's the asymptote. Everybody gets it right because, well, it's that last number. So -4 is also an asymptote. Make sure that's something that you get right. You basically shifted down 4, which is why we're now at y equals -4. We really didn't do anything with the base. That's on purpose because the only thing the base does is tells us if it's growth or decay. Remember, that base is less than 1. So thank goodness it's going to be decay because that's the only way to really connect these dots. Just make it work. I don't know. I kind of had to make a sharp turn, but it's a decay graph. It's going to go down because of 1/3. Tomorrow we will kind of dig a little deeper into like what's the meaning behind these numbers. Right now, the meaning is just some points on a graph. Remember, there was a mistake on number 1 on the homework, but I'm pretty certain everything else was good to go. And here's some things maybe you didn't check if you'd like to. Sometimes number 4 is a problem that people are like, yeah, can you just kind of talk that out a little bit? Sure. You start at 3. I'm looking at the front 3. Now, you kind of have to imagine like a little star here at 3. And then I shift to the right 1, but go up 4 more. So wait a minute, I'm right here at 3. I go to the right 1, and then I go up 4 more. That's why we have this point that's at 1, 7. Now the Y-intercept, again, that's always a good thing to go over. The Y-intercept for number 4 is trying to carefully work out 3 times 3 to the, well, can I just plug a 0 in and get -1 right away? So I'm trying to work that out. Now be careful, you got to do the order of operations. The order of operations says do the exponent first. Well, it's a negative exponent that is interpreted as a flip. So you can do that. You can do that without a calculator. That'll be a nice little 3 times a third, which is 1 plus 4. That's why we end up with 5. So the y-intercept is at 5. And then, of course, the asymptote is that last number. The graph's going to grow because of the 3. The graph's going to grow. That's why it has to go up as it goes through those points. How'd you do with the negative exponent here? It's going to flip the graph to actually be decaying. That is the right shape for that one. Now, eventually, we're going to ask you to do a mini check on this. If you're